before we start, just a wee quick word of thanks from the Donegal Engineers Ireland Committee region to Oisin and Luke for taking the time out tonight to offer this presentation. Oisin is an Associate Director at ORS. He's a Chartered Environmentalist with over 15 years experience in environmental consultancy. Previously as Environmental Manager and Plant Manager of Biogas and Biomethane facilities in Ireland. Luke Wymer is an Executive Director at John Spain and Associates. He offers expert experience in planning, including biogas and data center development. Just as the Donegal region, we hope to hold some more of these events over the next coming months. So I'd ask you to keep an eye on this platform just for upcoming events. And if I'll put the hand up if anyone is interested in getting involved in the Donegal Engineers Ireland region, by all means reach out to us, and we'll be glad and welcome of your help and support. So if I'll pass you over there to Oisin and Luke, take it away. Thanks, guys.
Thanks, Ronan.
Thanks very much, Ronan. And thanks to Engineers Ireland and particularly the Donegal branch for facilitating this evening's event. It's a pleasure to be able to join you this evening and discuss biogas, the process planning and the future. So Ronan has provided the introductions there, so thanks very much, Ronan. Myself and Luke will be delighted to talk with you this evening, and we'll welcome any questions you may have for the end of the presentation. So very quickly, just an overview of ORS and John Spain Associates, who we are and what services we provide to the biogas industry, but to development in general. So we're very much a multidisciplinary consultancy focused on 10 key areas, providing services to developers and development through all stages of development, from planning right through to construction and operation. So I won't go into too much detail here. We're happy to share some further information to anyone that's interested following the presentation. So please do reach out if you want any further information on ORS or John Spain Associates. Looking specifically at biogas and biomethane, suppose some of our specialist services at the planning and design stage are listed here. Over the last number of years, we've been heavily involved in the development of renewables projects, including biogas at different stages. So specifically to the biogas developments, we offer feasibility studies, obviously planning services, environmental impact assessments, right through to licensing and permitting. Also technical expertise through the environmental team at ORS and license compliance during the operational stage of developments. So the title of the presentation is Biogas, the Process, Planning and the Future. So we'll address the process first of all. So many on the call may be familiar with the AD process in general, but just to give a quick overview of the process, what's involved, and where we're at now in terms of the biogas industry in Ireland. Historically, the early development in AD in Ireland, and this would be true in Northern Ireland and the Republic of Ireland, would have been based on the model of, obviously your feedstocks are based on agricultural residues and wastes, with some industrial waste and food waste, fed forward to the digestion facility, the digestion tanks, which are generally operated at mesophilic range, 38 to 40 degrees temperature, mixed continuously to create the environment for the organic breakdown and decomposition of material to produce biogas. So in the early AD projects in Ireland, it would have been very much producing biogas for use as a fuel for CHP to generate heat and power, with power being generated for the national grid. So focused on biogas as a fuel for electricity generation and heat generation. So in recent years, there's been a move towards the upgrading of biogas to produce biomethane and biogenic CO2. So where the focus of the industry and the development of the industry in current years is focused on the supply of biomethane as a fuel to displace natural gas on the grid, or as a fuel to power CHP for electricity generation offsite. So 3 of the key products from the process are highlighted there. I'll go into more detail on those. So as I mentioned, obviously biomethane, which is generally an untreated biogas. Biomethane constitutes 55 to 60% of the content, with the remaining gas content being CO2 and some trace gases. So through the biogas upgrading process, we are left with 2 gas products in your biomethane and your biogenic CO2. Your biomethane, as I mentioned, it can be a direct replacement for natural gas and fossil-based natural gas. And biogenic CO2, which is recovered from the process, has multiple uses in industry. The final 3rd product there is Digestate, which is a high nutrient value organic fertilizer, which remains after the digestion process. And this is an excellent fertilizer and can be used to displace carbon-intensive chemical fertilizers in agriculture. The plant itself, so to touch on the scale and output from the types of plants that are being brought forward to planning in Ireland currently, the scale, certainly projects that we've worked on in recent years, is focused on this sort of range, the 40 to 60 gigawatt hour range for biomethane production. We've seen a focus on agricultural-based feedstocks, so manure slurries, supplemented with some crop feedstocks such as grass silage, maize, for example. And in terms of overall feedstock volume, this sort of 60,000 to 90,000 tons per annum annual intake from local sources, generally within 20 to 30 kilometers of the facility. So this is the output scale that is mentioned and generally supported in the biomethane strategy that was published in 2024. And we'll touch on the strategy further on in the presentation. At this point, we would like to just share an example project that we worked on in recent years as a visual guide to sort of talk our way through some of the key technology and infrastructure involved in a biogas plant design. So as a general overview, this is a project we delivered in 2022 that was successfully through the planning system in 2023. And to help visualize the process here, if we move from south, from the wood, if you can see the lorry there on the weighbridge to the south of the site, moving north through the site, as we progress forward, on the left-hand side there's a silage clamp. So standard silage clamp design, as you would expect in an agricultural operation. Here, the client has opted for a roofed structure with to maximize the space for solar PV on site. So this, again, as I say, the feedstock composition with this particular development is very much agricultural based. So some crop-based feedstocks with waste products, waste from agricultural operations such as slurries and manures. So there's a dedicated waste reception building there to the rear of the site, and that is a airtight structure kept under negative pressure with odor abatement attached to that structure, so you can see the odor emission stack just at the rear there, and we'll discuss odor abatement further in the presentation. Moving then, I suppose, in a clockwise fashion over to the primary digestion and secondary digestion. These are your digestion systems, so your organic feedstock is fed forward from within the waste reception building here through sealed pipework, fed forward to the digestion systems, and as I mentioned earlier, heated, generated between 38 and 40 degrees Celsius and stirred continuously to allow the anaerobic digestion process to take place. The secondary digester there is a design that may be most familiar to most people there, and that has the gas membrane holder above the tank there, which provides temporary storage of your biogas before the gas itself is fed forward for biogas upgrading. What's in the site as well, because the development of this nature is handling animal byproducts such as slurries and manures, pasteurization is a part of the process as well. All digestate material that's generated goes through the pasteurization process as your milk would, heated to 70 degrees and held for greater than an hour to ensure that any pathogens are eliminated. And this particular design as well, they've opted for a digestate separation and digestate dewatering system, so within the secondary structures there that we see on site. Moving to the gas treatment then, so as I mentioned, biogas upgrading included here, which in simple terms is a system that separates the biomethane from the CO2 and the trace gases. There's also a CHP plant on site to generate heat and power for the site itself. So the intention wouldn't be here to export electricity off site, it's to cover the parasitic load of the plant and facilities itself. And the biogas upgrading end of things then, your key product, your biomethane, is supplied to the national grid through the biomethane network entry facility located at the front of the site here. So this is your grid connection point where your biomethane, once it meets the appropriate standard, it's fed forward to the national grid through this facility. Also included here is CO2 liquefaction, whereby the carbon dioxide is captured and liquefied and processed that can be transported as a product off site as well. Very quickly, just to discuss some of the other elements of the site feed system. So within the feedstock reception building, generally a feed system of this type would be used for solid feedstocks such as manures, fed forward through a series of sealed pipework and mixed along with liquid feedstocks such as slurries to create a homogenized feedstock mix and fed forward to the primary digesters. Odor abatement is a key part of, I suppose, the appropriate storage of waste products such as manure and organic feedstock. So within the sealed waste reception building, often odor abatement systems are required. This is a license requirement as well. If the development meets the criteria for industrial emissions license, and odor abatement would be included as part of the design. Just there's a list there of different options for different types of odor abatement. I mentioned the CHPs there as an example. So in some cases, the CHP would be generating electricity for export off-site as well. But generally, our experience of projects to date, it's generally used to power the site itself using the site's own biogas and biomethane as fuels. The biogas upgrading technology, so there's different approaches to upgrading technology. They all work in the same principle in that you're separating the methane from the CO2 content. So there's multiple options there in terms of upgrading technologies. I mentioned the grid injection point. So the GNA have produced a standard design for their biomethane network entry facility that's visualized here. And this is infrastructure is included within the design of the plant itself. And And the technology within this tests and guarantees the quality of the gas before it is transported onto the national grid. So Digestate, again, a product of the process. It is can be used as a direct replacement for chemical fertilizers. So the benefit of Digestate in that obviously there's a huge reduction in the carbon intensity of this form of fertilizer versus the production of chemical fertilizers. So there's huge benefits to that. The benefit of Digestate as well, in that in the case of an EPA licensed facility, the Digestate goes under rigorous testing on a monthly and quarterly basis for nutrient value, as well as pathogens and metals content. So when this information is shared with end users, which are the farming community, this allows the farmers to apply the Digestate in accordance with their nutrient management plans, because they know exactly the nutrient value within that, whereas this information may not be available for untreated slurries. Options then for Digestate treatment. Again, I mentioned pasteurization. Separation, I suppose, is a simple first stage in terms of Digestate treatment, removing the liquid fraction from the fiber fraction of the Digestate. What you're left with then is Digestate fiber, which is visualized here in this image, very much like a compost type product, with the remaining liquid fraction, liquid Digestate. This liquid Digestate can be dewatered and processed further into higher concentrate Digestate liquid. And then there are also further options such as drying, pelletization, and nutrient recovery. So I suppose the benefits of Digestate use sits within the context of the cost of chemical fertilizers, both the financial cost and the environmental cost of chemical fertilizers. We've seen in recent years the cost of chemical fertilizers going through the roof. So there's benefits there, economic benefits for the farming community, as well as environmental benefits to the use of Digestate. And there's been a lot of talk about biogas and biomethane specifically in Ireland in recent years, and just touch briefly on the policy drivers behind that. I've highlighted here, not to go into too much detail on policy, but just to highlight the REPower EU strategy there in 2022 that was a result of at EU level a push to some energy independence from Russian gas supplies, a push to grow the biomethane sector across Europe, to move away from the reliance on Russian gas. So this set lofty targets for biomethane development across Europe, tenfold increase between 2024 and 2030 there. And in the Irish context, the Climate Action Plan in 2023 sets a target of 5.7 terawatt hours of biomethane production by 2030. So what this equates to really in real terms is 150 to 200 medium-scale biogas plants in operation by 2030 to achieve this 5.7 terawatt hour goal. This would equate to 10% of the total gas use currently in Ireland if the 5.7 terawatt hour target is achieved. And I've included a point here. I suppose it just highlights the role for biomethane within the overall energy mix in Ireland. Currently, 46% of our electricity generation in Ireland is powered by natural gas fueled power stations. So biomethane obviously is a direct carbon neutral replacement for that natural gas. So we're still very heavily reliant on gas as a fuel to create electricity here in Ireland. And I mentioned the timeline there, so 150 to 200 facilities in operation built and in operation by 2030 to achieve that 5.7 terawatt hours. So here we are in 2025. You know, it's a short time frame, and there's a lot of work to be done to achieve those targets. Why has there been so much talk in Ireland about biomethane development, and you know, where are we now in the biomethane development or industry in Ireland, and where could we be by 2030? So the current status where we are now, 40 operational biogas facilities in the Republic currently, generally, including wastewater treatment plants, AD attached to wastewater treatment plants. So the majority, as previously mentioned, are biogas to CHP. There are currently 2 operational facilities that are supplying and injecting biomethane to the grid. So currently that biomethane supply only meets 0.0001% of the gas usage in Ireland. So there's a significant amount of development needed if targets are to be achieved. And the background, I suppose, to Ireland's potential, which has been widely talked about, the EC has identified Ireland as having the highest potential for biomethane production per capita of any country in Europe. So why is that? It's because of our healthy agricultural sector. So we're all well aware of our reliance on the agricultural sector here on Ireland, and just to go into a bit more detail where we sit there in terms of the EU and biogas potential. So the study looked at the potential resources of manure for ED feedstock supply across Europe, and you can see we rate quite heavily there on the scale. In addition to this, our climate and our herd numbers and the current slurry supply available lend itself to significant feedstock supply for AD systems. So you can see here both slurry and silage. There is areas highlighted here that have significant potential supply of feedstock for AD, particularly in Munster, South Leinster regions, North Leinster, and then pockets in Galway and East Donegal here as well for slurry, and a similar picture then when it comes to the availability of silage as a feedstock for AD. Again, we not dwell, just to summarize, I suppose the CH4 production is sufficient to displace 15% of current commercial and industrial natural gas consumption. So in terms of the deployment model, then some sites will opt for direct grid connection to supply biomethane to the grid directly, but there's also the option of a virtual pipeline, which is a specialized, the biomethane would be compressed on site and transported by a specialist tanker to centralized grid injection points or CHP sites. Yeah, so it just looks, you know, here we are in 2025, so 2030 really, you know, we're only 5 years out from the 2030 targets, and that's just showing where we need to go really over the next 5 years. Significant amount of development needed. Much of our work within renewables and biogas development, site selection is key when bringing a site forward, proposal forward for planning. So just touch on some of the key considerations when assessing a potential site. So feedstock availability and proximity to the development. A key consideration is the availability of feedstock supply generally within a 20 to 30 kilometre radius of the site. And equally important is the availability of a suitable land bank for the spreading of digestate. So in this sort of cooperative model, you would have a number of farmers supplying sustainably sourced feedstock to an AD facility and then receiving Digestate in return, creating a local circular bioeconomy. An important consideration as well is the proximity to the gas grid. So be that when considering a site for a direct grid connection, or as I mentioned just now, virtual pipeline is also an option if not in immediate proximity to your grid, but within a sensible distance from a centralized grid injection point. And as with projects of this size and scale, and given their inputs and outputs, environmental impact is a key consideration when bringing a project forward for planning as well. So some of the key considerations on that I'll touch on, but the classification of project. If a project is processing greater than 25,000 tonnes per annum of waste products, it will meet the threshold for environmental impact assessment. Just to highlight that. Between myself and Luke, I don't know how many public consultations we've sat through in the last number of years on projects of this type, but over and over, the key concerns are air emissions, odor emissions, and noise emissions. So it's important to support any application with detailed analysis on all of those considerations. As with traffic, which is also another key consideration. So traffic and transport assessments are key as well to assess the volume and impact of traffic movements to and from the facilities. And landscape and visual impact as well is an important focus. So there are significant developments, within site selection. It's important to be cognizant of that when assessing the site and to build in landscape measures at design stage to ensure that the development is as sympathetic as possible to the local environment in terms of landscape and visual impact. So following the planning stage, assuming the positive outcome at planning, the next step then is licensing. So two important considerations, the statutory bodies here, the Department of Agriculture and the EPA. So dealing with DAFM first, the Department of Agriculture, Food and Marine. AD plants will require approval from DAFM to operate, as many will be handling animal byproducts, treating animal byproducts. They will require approval through the department and must be designed and operated in compliance with the guidance documents listed here, CN9 and CN11. So it's important to be very aware of the requirements of the department at design stage to ensure that all design requirements are included at an early stage of design prior to submitting for planning approval. And some of the considerations within that design to meet the ABP regulations and department requirements are around the storage and treatment of animal byproducts. So your storage and manures, how those materials are stored on site and how they're treated. That will include pasteurization technology as well as maceration, and to ensure that there's less than 12 mil particle sizes on the pasteurized material. Weighbridge is a key requirement to log all movements to and from the site, and biosecurity measures then, such as appropriate fencing and separation within the site and vehicle cleaning procedures. So it is a three-stage approval process really with the department. The first stage being the application AP11, which details the design and how the processes within the plant meet the requirements. Once approval in principle is received, then it moves to the second stage application, which goes into more detail in terms of operational procedures on the site, your hazard plan, and your validation plan. So within that, you'll outline your procedures in terms of testing of your digestate for E. coli and Salmonella and other potential pathogens, and your plant validation plan. And in terms of waste licensing then too, so I suppose the key considerations here are, firstly, it may be subject to a waste facility permit with a local authority if it's dealing with up to 10,000 tonnes per annum of organic waste. And the other consideration is a waste license with the EPA if above 10,000 tonnes per annum of organic waste. And then once you go beyond 36,500 tonnes per year, generally you're into the realms of industrial emissions licensing with the EPA at that stage. And in terms of EPA licensing, just important considerations at design stage are the inclusion of BAT and best available technology throughout. So that looks at your odor abatements treatment, your bonding, and your other measures throughout the site to ensure that any potential emissions are mitigated, managed, and monitored. So I think that's enough for me for now. I might hand you over to Luke to deal with some of the planning policy and guidance.
Thanks very much, Oisin, for that. So we'll really just give you a quick whistle-stop tour, and it's really a snapshot of where we're at the moment in terms of planning policy, and some of the processes around getting these plants through the planning system. So we can move on maybe to the first slide there. So I guess starting out at the highest level from a planning policy point of view, obviously the National Planning Framework published in 2018. There's very strong policy support in there for renewables development. The current version of the National Planning Framework doesn't really get into biomethane in too much detail, but many people will probably be aware there's an ongoing process to replace the 2018 document, draft published last year, I think in the late spring, consulted on in the summer, and some updates published in November. So we're eagerly awaiting that. But in summary, that does have a much stronger policy support directly for biomethane, and it follows on for the biomethane strategy that was published by the government last year as well. So we'll touch on that in a bit more detail. The next level down from that, then, you have your regional, spatial, and economic strategies published by each regional assembly. Again, there's good support for renewables broadly in those, for circular economy, and limited enough reference to biomethane, but something that we'll probably see feed through a bit more strongly following the update to the NPF. I guess where we see the most, which is typical, in terms of each county's plan being different, we see the most variation there is at the county plan or city plan level. Not that we're proposing to build these in any cities for the time being anyway. But there's a high degree of variability there. Some county plans pushing biomethane plants towards industrial estates, closer to built up areas, whereas others would recognise the importance of locating them close to major sources of feedstock. So that might be an intensive agricultural installation like a large-scale dairy or a piggery or something like that. We'd probably, I suppose, Oisin and myself, probably consider the latter of those approaches to be the more appropriate. Locating these, there's been examples, I suppose, of operators trying to locate near to or within built-up areas or industrial areas, or business parks, and there's tended to be a higher degree of, let's say, dissatisfaction with that. A couple of legal challenges that we've seen come up as well. So broadly speaking, the projects that we've been working on, and there's a good few of them, they're located in more rural locations, directly proximate to major feedstock supply, and for the most part, with the ability to directly connect to the national gas grid as well. So we'll probably move on. So in terms of the biomethane strategy, it's only really starting to feed through in the more recent decisions that we've seen. But it does provide a good, strong level of policy support for the industry in principle. It, in my opinion, probably does lack a bit of detail to assist planning authorities and the board in considering planning applications for biomethane facilities. There was a promise in there of a code of practice for planning authorities, which I think would be a really, really good idea, but I don't believe it's been finalised as yet. So that'd be something that would really help to move things on, in my view. Again, we'll get to it further in the later slides, but you know, the clarity of planning policy and the actual process that these have to go through from a planning point of view, it's going to be one of the key determinants of whether we actually meet the targets set out in the climate action plan. Well, the last two, the current climate action plan, the previous one, the biomethane strategy, there's a fairly heavy commitment there to reach that 5.7 terawatt hour target by 2030. But as we'll see, that's a real challenge, and we're probably already significantly behind the pace we need to be at to hit that. So moving on to that aspect of things, we've just kind of visualized the current pathway through the planning process, including the preparation of the application. And this is based on the procedures and timelines as they currently stand. We're going to touch on the Planning and Development Act 2024. That's been passed, and it's an act, but it hasn't been commenced for the most part. So that's going to come in later on this year into next year. So as Oisin touched on there, the first stage that we generally recommend is kind of a high level feasibility study, and I guess between John Spain Associates and ORS, that would kind of cover off really the majority of the different areas that you want to do due diligence on, from planning policy, I guess, all the way through the detail of environmental factors that might be impacted, or proximity to European sites, etc. So we have 3 months in there. That could we generally turn those around a bit quicker than 3 months, but some of these stages at the very start could probably be telescoped to some degree. In particular, the next two stages, so the kind of plant design, public stakeholder consultation, that's something we've generally undertaken, or clients have undertaken on off their own bat, to kind of consult with local people, get farmers signed up, with kind of intention and principle to supply feedstock is another quite helpful thing to have before you lodge your application, and obviously undertake consultation with the local planning authority. So that's there in the next step for the planning application preparation stage and the EIR. Again, kind of a 3 to 6 month process, and that is fairly heavily dependent on the likes of survey seasonality for biodiversity or ecology surveys. So depending on the site's particular sensitivities or location, you might miss. When you come to a site, you might have just missed a survey window and have to pick something up at a later point in the year or something like that. So yeah, generally that's probably an accurate representation. So then at that point, you're ready to submit a planning application to the local authority, and that's a 2 month process that we'd all be familiar with. The first 5 weeks of that being public consultation, where people can make submissions. Most of the applications for biomethane plants are subject to further information requests, partially just due to their scale. But equally, I'd say, because most applications being made at the moment are probably the first or maybe the second such application to be made for kind of a in recent times, I guess, for this type of development in any given county. So there's a fairly steep learning curve, I suppose, for I guess, you know, that we would have been through in terms of getting to grips with them and preparing a robust application, but the planning authorities are also having to go through themselves. So we've given ourselves 1 or 2 months there to respond to an FI request, which isn't too bad. Then, assuming there's an EIR, which most of these, or if not all, large scale ones, there will be. There's a 2-month window there, or sorry, indeed, if they have a mature impact statement with them, it's a 2-month window then for the planning authority to make a decision, followed by a 1-month appeal period. And anyone who's made a submission, but also some NGOs who haven't, even if they haven't made a submission, they can appeal the decision of the planning authority to the board, as can the developer if they're not happy with any aspect of it. So as it stands, we're kind of this is obviously a moving target in terms of the board's timelines for deciding appeals. It had kind of gotten to a point where it was over a year. It still is for many cases at the moment, but we'd estimate maybe that cases going in at appeal around now or in the next few months, hopefully it will have come down to more of a 6 to 8 month timeline, or even hopefully even less. The backlog has been significantly eroded over the last year or so. So after the appeal process, I suppose a final planning decision is made, and there's then an 8-week window where again the developer or third parties, if they have sufficient interest, could seek a judicial review of the planning decision. There's been a couple of JORs on biomethane plants, a couple of overturns actually of grants of permission, but overall not a particularly high incidence that we can see so far, and we'd obviously be hopeful that stays on the lower end. There's obviously been an increased prevalence of JORs over the last 4 or 5 years, so it'll be interesting to see how that pattern works itself out in terms of this particular type of development. So yeah, I guess overall you've got a planning timeline there of up to kind of the low 30s in terms of months. So that's a considerable timeline. And Oisin will just touch here on the broad timeline for licensing as well.
Yeah, so obviously an important consideration is the licensing aspect of the development as well. And if a development is of the scale where it meets the requirements for industrial emissions licensing, what we're seeing from experience over recent years, the current timeline from submission of a license application to a decision is in the range of 12 to 18 months and sometimes much longer. So it's an important consideration in terms of the overall timeline of development. Within the biomethane strategy, there is the goal or the objective there to resource regulatory bodies such as the EPA and Department of Agriculture to address some of these hurdles in terms of timeline and assessing applications to try and speed up progress in the industry. So yeah, that's what we're seeing in terms of licensing, realistic timelines there. And all that's before you're even into your construction timeline. So
then you have to build the thing.
Yeah.
So I think on the next slide then we've kind of roughly plotted that out against there's some irony in the fact that the biogas plant there looks like a snail, but the timeline in terms of getting one of these things through planning, licensing, and actually constructed and producing biomethane, we're already coming dangerously close for current projects kind of being kicked off to, at a worst case scenario, obviously assuming an appeal and the rest of it, coming quite close to that 2030 deadline for 5.7 terawatt hours. So that's obviously a pretty worrying metric. We're hopeful it's going to improve. The timelines will come down, but they really need to if we're going to have any chance of meeting that ambitious target. And I know there's been similar analysis done by the likes of Wind Energy Ireland, looking at the issue that we have with wind farms and the permitting process there and how long it takes, and how that stacks up against a 2030 deadline to avoid significant fines. So there is a challenge there for sure. It's the one thing to say is it's pleasing to see there's an awful lot of interest and a lot of movement in the industry in the last year and a half, 2 years. Lots of projects coming forward. So there's at least there's a good inroads into the numbers that we need to be seeing coming into the planning system at the moment. This is just an example. I won't dwell on it, but there you go. That's kind of the worst case that we were talking about, except for it excludes the JOR. So it's about 3 years there. So there probably is some cause for hope, hopefully. One thing that we've seen in the last year in particular is there has been increased resourcing of Ardmore and planning authorities, with hundreds of additional posts being announced and largely filled, I think, in those bodies. So that'll improve the efficiency of the planning system, which was really under terrible pressure in terms of the sheer numbers. Again, as I mentioned, appeal timelines are reducing, but they still remain high. They and other types of application processes will be subject to new mandatory timelines under the new Planning Development Act, which I'm going to touch on really quickly after this. Overall, I think there's decreased incidence of judicial review in some types of development, but greatly increased in others. So there's probably not too much of a pattern yet to talk about in biomethane. But again, as I said, we'd be very hopeful that the robust planning processes that they're all going through may help to reduce the incidence of JOR. We'll have to wait and see. And then, yeah, I suppose the timeliness of the JOR process is a big thing as well. That could take years in some cases. But there's a couple of examples recently of planning JORs moving their way through the courts very quickly, like the Cool Glass judgment on a wind farm from, I think it's only a few weeks back. That made its way through the court system within about 3 weeks. Now I think the board are going to appeal it, so that'll take more time, but it's certainly good news that something can make its way through the High Court that quickly. So now look, just very briefly touching on the new Planning Development Act. I'm conscious we need some time to answer your questions. There's changes to statutory timelines there. So the 8-week timeline for a standard application without an EIO or NIS hasn't changed. Where you do have an EIO or NIS, there's a 12-week decision time, which only starts on the last day for submissions or observations on the application. So that's quite a lengthening there. And it's an 8-week timeline if FI is sought. If there's an EIO or NIS, that's the same as it currently is. In terms of appeals, it's 18 weeks or 26 weeks if there's an EIO or NIS. And then I think on the next slide, we just, if there's an oral hearing, it's 10 weeks decision timeline from that concluding. If the board requests FI, it's another 6 weeks, or 10 weeks if there's an EIO or NIS. And there's different procedures now for exceedances of timeframes. So there is kind of more of a stick there in the legislation for timelines being missed. And I think the rhetoric from the board is that they're going to do their absolute utmost to meet those new statutory timelines. And it'll be great to see that happening, kind of return a bit of certainty to the process. On SIDs, we didn't really touch on them, but there is a threshold there for waste facilities or treatment of waste over, is it 100,000 tons, I think, Oisin, off the top of my head.
Yeah.
So we haven't seen, I don't think, any AD or biomethane plants going through the SID processes yet. But it is available to people if they do exceed that threshold, and if they satisfy the kind of the strategic criteria under the current act. So under the new act, there's a 48-week timeline for them for decision, on top of your public consultation period, which I think is minimum 6 weeks, but generally advised to be around 7 weeks. So you're at the guts of a year there for a SID application still under the new act. So maybe that's a relatively generous timeline, I guess, that SID takes in some very large scale developments though. So very briefly then, there's a couple of sections in force already, but they're not too important for the current discussion. One of them is just the rent pressure zones bits, and then the kind of the long title, I think, of the act. The very first section, I think, has been commenced as well. The department have been given quite a bit of guidance now in the last couple of weeks on commencement, and it's going to take place over the course of this year and into next year. Next bit to be commenced is the restructuring piece on Onboard Planola and renaming it to Commission Planola. There is a dedicated website we can maybe share after the session today that sets out the indicative timeframe for the various sections coming through, including those for application procedures and appeals, etc. And the regs haven't been published yet, but they're going to be published alongside each chunk of the Act that's commenced in the near future. There will be a public consultation on some aspects of that, including EIA thresholds and indeed on the exempted development provisions as well, because they were taken. There's no exempted development provisions, specific exemptions in the new Act. They have all been left over for the regs. So that's a quick overview. Hopefully not too quick or too rushed, but we'll get to any questions now, I think.